Hi, good morning dear students. I am Shiraz with you. Today we discuss about design of Dolph Tchebyscheff array. We first recollect uniform and binomial array. In the case of an uniform array, we know that it have a greater directivity. The reason is that the major lobe beam width is smaller. But the drawback of the uniform array is the increased side lobe. Then we move on to binomial array where it have lesser directivity because the major lobe beam width is higher, but it have a smaller number of side lobes. We identify a gap between these two types of arrays. That means there is a trade-off between directivity and side lobes. This leads to a new kind of array known as optimum array. Here, for an acceptable side lobe level, we can minimize the major lobe beam width. This means that we can increase the directivity, and this is termed as Dolph-Tchebyscheff array, and it is proposed by C.L. Dolph. Next we move on to Dolph-Tchebyscheff array. The design of this array make use of Tchebyscheff polynomial. That's why we call it as a Tchebyscheff array, and the polynomial is defined as Tm of x is equal to cos m cos inverse x, where mod x less than plus or minus 1. Let's check what is Tm of x for different values of m. Let m is equal to 0. We know that T0 of x, that is equal to cos 0, that is equal to 1. Then if m is equal to 1, that is T1 of x equal to cos 1 cos inverse x, that is x itself. Then put m is equal to 2, then T2 of x is equal to cos 2 cos inverse x. Then we can substitute cos inverse x is equal to psi by 2. I hope you remember what is psi. Psi is the phase difference and its value is beta d cos phi. Then we just modify T2 of x, that is cos 2 psi by 2 equal to 2x square minus 1. That means cos 2 psi by 2 equal to 2x square minus 1. How is it possible? We know that cos inverse x is psi by 2. From that, x is equal to cos psi by 2. Then we know the identity cos 2 theta equal to 2 cos square theta minus 1. Using that identity, we can write cos 2 psi by 2 equal to 2 cos square psi by 2 minus 1. Then we know that cos psi by 2 is x. So cos 2 psi by 2 is equal to 2x square minus 1. Therefore, T2 of x can be written as 2x square minus 1. Similarly, T3 of x is equal to 4x cube minus 3x. T4 of x is equal to 8x raised to 4 minus 8x square plus 1, like that. Okay, so here the Tchebyscheff polynomials are represented in terms of x. In order to design Dolph-Tchebyscheff array, we need to know these expressions. There is an easy way to find the expression if you know the initial terms. And the expression is that Tm plus 1 of x is equal to Tm of x into 2x minus Tm minus 1 of x. Let's check an example. Put m is equal to 4. If m is equal to 4, you can find T5 of x, and the expression is that T5 of x is equal to T4 of x into 2x minus T3 of x. But you must know what is T4 of x and T3 of x. So substitute that expression here. You will get T5 of x is equal to 16x raised to 5 minus 20x cube plus 5x. Let's check it. Then we move to the design. First we consider even number of sources denoted by NE, where the suffix E represents even number of sources, and the arrangement of the sources is shown here, where the amplitude of the center two sources are assumed to be A0 and the next pair as A1 and next one is A2, like that AK pair of sources. Then we check what is the relation between K and NE. Okay, the antenna arrangement is shown in the figure. Let's take 4 sources. The corresponding amplitude pairs are A0 and A1. That means K is equal to 1. If we take 6 sources, Then the amplitude pairs are A0, A1 and A2. That means K is equal to 2. If we take 8 sources, the amplitude pairs are A0, A1, A2 and A3. That means K is equal to 3. In general, we can write K is equal to NE by 2 minus 1. Okay, that is the expression. K is equal to NE by 2 minus 1. That is the relation between K and NE. Then we check the total field due to the pair of sources, and the total electric field is given by ETE, that is equal to 2A0 cos psi by 2 plus 2A1 cos 3 psi by 2 plus the remaining term till 2AK cos psi NE minus 1 divided by 2, where psi is 2 pi by lambda into d sin theta. What is the reason for using sin theta here? Normally we use cos theta, but here we use sin theta. The reason is that we arrange the antenna elements along the horizontal line. Okay, that's why we use sin theta here. Then we can find the total electric field as ET is equal to 2 into summation over K varies from 0 to NE by 2 minus 1 AK cos 2K plus 1 by 2 psi. That is the general expression. Similarly, we consider odd number of sources, and odd number of sources denoted by NO. Suffix O represent odd number of sources, where the center source is assumed to be fed with 2A0. Center amplitude is 2A0, that is shown in the figure, and the relation between K and NO is given by K is equal to NO minus 1 divided by 2, and the total electric field is given by the expression ETO is equal to 2 into summation over K varies from 0 to NO minus 1 whole divided by 2 AK cos 2K by 2 into psi. That is the general expression. The total electric field of the sources is given by these two expressions. In this expression, it is clear that we can neglect the term 2 because we consider the relative amplitude. Then the Tchebyscheff polynomial Tm of x equal to cos m psi by 2. By substituting that in the expression, above expression, we can reduce the expression as total electric field of even number of sources as ET equal to summation over K AK into T 2K plus 1 of x. For odd number of sources, the total electric field ETO equal to summation over K AK into TK of x. Next we move on to the design procedure. Then first step is you must find the value of R. Sometimes it may be given in the question, otherwise you must find the value of R, where R is the ratio of the main lobe maximum to the side lobe level, or it can be defined as side lobe level below the main lobe maxima in dB as 20 log R to the base 10. Okay, then second step is select the polynomial in such a way that m is equal to n minus 1, where n is the number of element in the R. The third step is that you must find the value of x. Okay, after finding the value of R and m, substitute those in this expression, you can find the value of x. And you must ensure that the value of x should be in between minus 1 and plus 1. Otherwise, scale it down by defining a new variable x dash by x. And the final step is that you must equate the array polynomial and the Tchebyscheff polynomial and find the coefficients. That is the final step. Let's check a problem. The problem defined like this. Design a 8-element broadside array of isotropic sources of lambda by 2 spacing between the elements, and the pattern is to be optimum with a side lobe level of 26 dB down the main lobe maximum. So first we can check what are the values given. Here the element is 8-element broadside array, so number of element is 8, and the spacing between antenna element is lambda by 2, that is d is equal to lambda by 2. Then we can find the value of R. because it is given like that in dB as 26 dB. Okay, so you can find the value of R as 26 equal to 20 log R to the base 10. Then calculate the value R as 19.95 and it can be approximated as 20. Then we design for 8 sources. So NE, even number of sources, equal to 8. N is equal to 8. Then M is equal to N minus 1, that is 7. We know the Tchebyscheff polynomial for the order 7. T7 of x is equal to 64 x raised to 7 minus 112 x raised to 5 plus 56 x cube minus 7x. Then solve for x, because we know the value of R and M. Substitute those in the expression. Then you get the value x is equal to 1.15. Okay, and you know that the value of x must be in between minus 1 and plus 1. Here the value of x is greater than 1, so we should scale it down, and it is defined by the new variable z. Z is equal to x dash by x. Okay, then we can write the expression for total electric field as Et is equal to 2 into summation over k ak cos 2k plus 1 by 2 psi. Then here total number of element is 8, so you can get the expression for E8 as 2a0 cos psi by 2 plus 2a1 cos 3 psi by 2 plus 2a2 cos 5 psi by 2 plus 2a3 cos 7 psi by 2. Then I already said that we can neglect the term 2 because we consider the relative amplitude and the Tchebyscheff polynomial Tm of x is equal to cos m psi by 2. Using that expression you can find E8 as then a0 into z, because first cos psi by 2 is T1 of z. Then 2a2 into cos 3 psi by 2. Cos 3 psi by 2 is equivalent to T3 of z, because here we use z because the value of x is greater than 1. So we scale it down by another variable z. Z is equal to x dash by x. That's why we use the z here. Then the third term, that is 2a2 into cos 5 psi by 2 can be replaced by, instead of cos 5 psi by 2 you can use T5 of z. Then cos 7 psi by 2 can be replaced by T7 of z. Then you can find the last expression Ez as a0 into z plus a1 into 4z square minus 3z plus etc. in terms of z. Equating the total electric field E8 and the Tchebyscheff polynomial T7 of x, you can find the amplitude levels. And one thing you must note that z is equal to x divided by 1.15. Then equating E8 and T7 of x, you will get the amplitude level like A3 is equal to 2.661 and A2 is equal to 4.55 and A1 is equal to 6.78 and A0 is equal to 8.167. Okay, then we find the relative amplitude, so we can divide this amplitude level by the smallest value, that is 2.661. that is the smallest value of A3 is the smallest value, divided the entire amplitude by A3, you will get the relative amplitude as A3 is equal to 1, A2 is equal to 1.7 and A1 is equal to 2.55 and A0 is equal to 3.07. Thank you.